Now, before we start with getting into Jenkins, specifically, we need to understand this word called continuous integration. So, why is it required? And why is it of such a huge importance, specifically in DevOps? Okay, and that's what we need to understand. So, before understanding that, let's first understand what was the requirement. So, now, typically, let's go back to the SDLC. So in the SDLC, we know that there's a group called developers who'll be writing code and they'll be using some SCM tool to store the code. And then what will happen? So let me put it up in that way. So you'll have developers, and once they finish the code, what will happen? So they will check in, right, or commit. So once the check-in happens, it'll get stored into some kind of SCM tool. And then we will have engineers called build engineers or pretty specific some engineers who takes care of integrating all the code. So what is the job of this person? So he'll integrate the code, whatever that has been written by different people, because you're not compiling just one component or one file. You are always compiling as a product, and you create the product, right? So once you create the artifacts or deliverables, okay, so we can call it as artifacts, and then what will happen, we will give it to QA, wherein they go ahead and do the testing, and then the cycle keeps going on until everything is fine. So this is what we know from a theory so far, but let's dig in a little deeper and try to find what happens. Now, when you say how many developers are there, so literally there'll be huge number of developers, and the number of check-ins that they're going to do will be huge. But is it going to happen in the same time at the same file? No. Logically, everyone will have their own time to do it based on when they are completing their task, and the priority changes. So in that case, what will happen is, now when you are trying to work on a release, so the very olden days, what they have to do is they will keep a cutoff date. So they'll say that, hey, okay, let's do the development until this day, and once in 15 days or so, we will try to keep on developing, and then we will do the internal testing, and after that we will check in. Then when we check in, we will create everything and then do a build, and then we will give it to the QA. So that is what the earlier days, like I'm talking about a decade back. So then people wanted to do things at a faster rate, because as we saw in the very first class, the requirement is that we need to deliver things faster. So in that case, it is not ideal. So now what they started doing is they wanted to do things on a daily basis, because that's when we started adopting the modern software development methodologies like agile, right? So what do you do in that? Basically, I would believe that many of you might be implementing some kind of agile methodology or something at least called Scrum. So you will have daily tasks to do. So that's when whatever that you try to develop, you have to test it on a daily basis, because waiting for 15 days, you're keeping everything idle, right? So that is when they wanted to break the product into smaller and smaller pieces or components and take one by one and test it and try to achieve the goal, rather than accumulating everything and doing it at one large chunk, which will be again a problem later. So by this way, if you do on a daily basis for a product as such, there'll be many people who are doing changes. Like I said, if you have a product with some huge number of components, different users will be doing check-ins for different components, for different releases, or for different features. So now in that case, now whenever you're going to give some content to a QA as a deliverable, or as an artifact internally or locally that we call, it has to be a complete product, right? So what they started doing is, now in that case, they started adopting a concept called as full build or nightly build. So what it means is, now if we set up a process at the evening because in those days, when you do a build of a complete product, it used to take a longer time, like 6 hours, 7 hours, or even more than that, or something close to that, depending on how big your product is, what and all steps you are trying to do in it. So now, in that case, what they will do is they don't want to waste the time in doing the build during the business hours, waiting 8 hours of a day. So, what the concept they came up with is something called as nightly builds. So, nightly builds or full builds, as the name says, it is a complete build of the product, or you're completely building a product every night and once in a day. So when do you do it? So basically, you fix some time after the business hours where the developers will not do anything, or they would have completed their activity by that day. So probably around after 6 p.m. in the evening, sometime like that. So until then, what will happen is, so until 6 p.m., whatever check-ins that the developer will do, they'll be modifying everything and checking in. So at that cutoff time that you have created a schedule to do a full build, so at that point of time, you integrate all the days changes, whatever that you have done, and then based on that latest change that is going at 6 o'clock or whatever time, you try to do a build. And that build is a full build of the product. And sometimes some companies call it as full build, some people call it as nightly build. Okay, so once you do it, you will be then running it over the night or a couple of hours, and then when the QA comes in, they will be able to take the deliverables next morning and work. Suppose if on the current scenario we will have teams across the globe, so say if it takes 5 hours, so by 6 o'clock you trigger the build, just as an example, so by 11 o'clock, it should be completed. So if people in other regions like US or UK or pretty much any other where, if they want to pick it up, it will not be a complete day waste for them because it will be the early morning. When they come to their office like around 10 o'clock, things will be fine. So they can go ahead and do the testing, or they can go ahead and complete the further tasks from there. So like this, they would follow this concept of doing a full build. Okay, now this is what typically every company are doing uh, majority of the times as of now. So this is how you check in the code, you take it, you build the product, and you give it to the QA once in a day. Wherein this could be at least once or twice a day. It depends on the product. Sometimes if the time that you're using for creating the build is very less, they might do it once or twice. Okay, that is the concept that people are doing. Now, if you look at this, it is a good way that the practice they are following. But let's take a scenario where there are 10 developers who are modifying, okay, on that day for that release. So one developer, he did a change early in the morning, and then thereafter, one by one, developers are modifying. Okay, now it looks like the developer who did the very first change early in the morning, his change is not compatible with some other change. He did something which is not going to work. And it was not found because when he tests or when he does a developer build on his local machine with his modified files, only that component will be tested. So he says it is fine. But the reason why we integrate and do as a full product is because we think as a product, not just as a component. So we have to make sure everything is created and is working fine. So at that point of time, say at the evening when you are doing a full build or the nightly build, what happens is that the build breaks. That means the compilation step, or somewhere while creating the product or doing the build of the product, there will be a error found, and it is that because of this person. So now what will happen is we will know the error only in the night, wherein there will be no one to look at it, or pretty much you have to give it back to him on only on the next day. Wherein, if you see, for one small things like this, even when we know it is going to take at least one day, but let's take a scenario wherein you have more than 10 changes, and when something fails, it could be that the same file was modified by more than one person. So it is not easy to just directly say which is causing problem, because the same file has been modified by many people and many other changes have gone. So debugging these changes and finding out what exactly caused problem and assigning it back to the developer is a critical task, and it is a time consuming process. So now in this case, if you look for a smaller issue, it is going to take at least 2 days. I don't know, it might be lesser than that or it might be more than that, but on an average you'll be spending at least 1 day, which is going to be a waste of time, right? The more complex things it fails, it'll take longer time. So this is how by the next day, by 6 o'clock or whatever time that we have given for the build, if the fix is not given, the next day will also be a failure build and you will not have a complete build of the product to test, right? So in that case, until you keep it, it'll be tedious process wherein nothing will work. The developer is also under pressure and QA also doesn't have anything to test. Okay, so this is when we needed a better process of improvement. So the focus here that was required is how can we reduce this time which we are putting into this much of amount of waiting, and how can you help the development process to find out these kind of bugs at a faster rate. So people started adopting many different ways, but if you look, all these things could be of different names that they follow, but in generic, this is called as a process improvement, where you will help the developers to try to find out the problems as early as possible. Okay, so that's when continuous integration as a process came into the picture. So before getting it into it, so you're getting what exactly is the problem that will happen, because you assume bigger the product, whatever that I said will be little more bigger. I'm just squeezing it, I'm just trying to give it in a way to understand. Okay, so getting with the problem, what's going to happen other than the code checking and the QA testing? What happens in between?
Adam, like Jenkins, we are doing the build and we are getting the binary.
I'm not
Yeah,
going to
that's it, right?
Jenkins. I'm not going into Jenkins
Okay.
at all. I'm talking about the process.
Process. Okay, fine. Then.
I'll come to Jenkins. So the point here is, did you understand what happens? Probably you might also be
Yes,
doing
yes.
the same thing or something similar. And what is
Yes,
the
yes.
problem that you're facing? Dhruva, Varun.
Uh, yes, Adam.
So you can correlate something to a similar step what you're doing. Okay, I'm just giving it in a generic way. I'm not going in very deep because there might be some other steps, but on a generic way, what you'll be doing. Okay, so what is that we can do to overcome? So we have to put in a process called continuous integration, which will help. Now, what exactly is a continuous integration, or what is that process? So now, if you look, we need something to be tested at a faster rate so that we don't do this at the end of the day when we have to give it to the to the QA, because whenever QA is going to take, they will always take the output from this full build, because it is a full build of the product. Because if you miss something inside it, you cannot just give it as a product. A product means you have to build it fully. So whatever QA has to take, this is the one that you have to take, right? Okay, so now setting it apart. Now, can we do something wherein if we can integrate these two stages in a better way so that we can get the notification or identifying the problem faster, is what continuous integration talks about. So first thing what continuous integration says is, let me just break it up. So now the concept is very simple. Now, why is that you have to wait until evening or some point when you want to integrate everything and test? Because you are accumulating, right? So rather than accumulating and doing the build at the end point, why don't we do it at the same time when a developer submits a code. So that means now if a developer is doing a check-in, if we can immediately do the build and verify whatever that he has submitted is good to be added to the product, so that you are not just checking only from the component, but you are also checking on the dependency and ensuring that as a product it'll work fine. So that kind of step what you're going to do and verify is what continuous integration is. So this way a developer doesn't have to wait, or the process doesn't have to wait so long. So what is that you're going to do? We are going to do this integration and the build for every check-in that the developer does. Okay, so how can you do that? So now basically we can create one process, a build step, wherein what this build step is going to do is this is going to integrate whatever the latest change that you have and do a build. Okay, the same thing. The difference here is you are not integrating all the changes. You are integrating only the check-in which a developer has submitted at that point of time. Now, the question may occur that what if two developers are checking at the same time? So even though two developers are checking in, which one will you always refer? You will always refer the latest. So when you say the latest, whoever does this first commit, he will have a check-in, and after that, whoever does it, it will be on top of that check-in. So if you refer to the second check-in, you will have the first check-in content itself, right? So that way, you will always take at that point of time what is the commit which is latest in the branch or in the repository, and you take it. Specifically, you just try to get. So how do we know at what time a developer is submitting a change? Okay, so this way, how will you know this is we need to set a polling mechanism. So polling mechanism is we want this step to happen as soon as a developer is submitting a check-in, or for every developer who submits a check-in, we need this to happen. So in that case, we need to keep on monitoring a repository. That could be any repository that we are going to use. So monitoring in the sense, keep looking whether you are getting a new commit or a check-in or a new version that is coming. So that in terms of the SEM is what we call it as polling or poll SEM. Poll means monitor a particular repository and try to see if you have any changes, which means any new commit that is happening. So now, respective to a repository for the product on your working, you will be doing a poll. Now, as soon as you find a check-in that has been submitted, what will happen is this step will call the next step called build, wherein you found a new check-in. Hey, I found a new check-in by a developer. Go ahead and do the step, whatever you want to do. So now here, if you see, it will not be the complete day, but at that instance, whenever a developer submits a code, you will take that and you will integrate. Okay. When you are doing an integration, you will use a single workspace for working. So here, when you're doing a full build, you will always try to create a new workspace and do the build freshly by creating a scratch workspace, syncing everything into the workspace. But here, we are not going to give it to the QA because this process is only for the developers, not for the QA. So what we are going to do is we are going to use the same workspace. Okay. So on the workspace, for the first time, say if a developer submits a code, I will sync it. Okay. Now, the next time, if a developer checks in, if I sync or do an update, will it sync everything? No. Logically, you have all the other files, right? For example, you take 10 files in a repository. Okay. So for the first time, when you say update your workspace or sync your workspace, it will sync all the 10 files, because if it doesn't have anything in the workspace, you are checking out or you're creating the workspace with all the 10 files. Now, after some time, say there is a new check-in wherein a user has modified 2 files. So then if we do an update or sync in the same workspace, what will happen? Only those 2 files will get updated, right? Because it will not sync everything. All the remaining files are the same as the repository what we have. So it will update only those 2 files. So this way, we are going to reuse the same workspace and keep updating internally or integrating with whatever new changes that you happen. So that way you are actually integrating all the code. So like I said, if I have 10 files and out of that 10 files, if one user does the modification, what will you do? You will just do a sync or update so that this workspace will get updated with the latest one file which is modified. So in that way, this workspace is completely integrated with all the latest change that has been submitted. So next thing, in this workspace, you're going to do a build. So this way, if you look, the time that you are using for syncing or creating or integrating everything is very, very less because you're not updating everything. You're updating only the modified files. So it'll be very fast. Second thing, if you do a build in the sense compilation. So if you do a build, what happens generally for 10 files that we have, you will be getting corresponding 10 object files. For example, if you take Java, for 10 Java files, you will get 10 class files, and then you will create a jar file out of it. Okay, just an example. But if you do this here, every time that you work, it will be actually based on a new workspace. So when you say new workspace and when you sync this 10 files, there is nothing available. So you have to rebuild all the 10 files once again. But here, for the first time when you build, you will be building that 10 files. That means 10 compilation that will happen. Now, the next time when I said when a developer modifies only one file, you will update or sync only one file. And when you try to build, how many files have been modified? Only one file has been modified. So correspondingly, only that one Java file will get recompiled and all the remaining 9 files, there is no modification. So the corresponding output file like class file has already been present here in the same directory. So you can reuse it. So when you create the jar, it will use the new class which is compiled based on the modified file, and it will reuse the same 9 class files which it was built last time. So like this, every time when you integrate and do a build, you are not doing a full build. You are just doing a incremental build. Okay, so incremental means on top of what we have. So now if you see, I have built all the 10 files, I have created one jar file. Now next time if I modify another one file, the one file will get updated. And then when you do the build tool will check and verify saying that, hey, you have modified only one file and corresponding to that, I will compile only one file. But do I have all the remaining 9 class files to create the jar? It is there. If it is not there, then it will create everything. But in our case, it's already there. So it is just going to do a incremental way and create the build. So this way, the time that you're going to take for the build step is also going to be very, very fast. And as I said, you are not doing a full build of the product. You are just ensuring those steps, which is bare minimum to qualify that the check-in, whatever is done, is okay to proceed as a product. Okay, so by this, if when you do this build and in case if there is a problem, then what will you do? You will immediately report it to the developer, or you report based on whoever or what is the policy the company will take, they will work on fixing it. So this way, if you look, if a developer is submitting within very less amount of time, like not like 5 hours, it will take less than 15 to 20 minutes or maximum 40 minutes, you can find out what is the problem that has happened. So it is beneficial now. Say if a developer is checking in code at 10 o'clock, maybe by 10:30 or 11 o'clock, he will know what is the problem and he will go ahead and fix it so that by evening 6 o'clock or whatever time, when they are trying to do the full build of the product, he would have submitted the fix and everything is good to go. So that when you do the build here for the complete or the full product, nothing will fail. Getting it? So continuous integration is such a process wherein you will be monitoring the SCM. That is what we call it as polling. And for every check-in that happens, you trigger a build process, wherein the build process that you do will be an incremental process by which things will be happening faster. And in case if there is any issue, you go ahead and indicate to the user immediately so that you don't have to wait. Okay. Now, say there might be another question. Okay, you said you do a build at 40 minutes. Now, after completing this, once again, it will start checking in. Checking whether, or that's why I use polling. Okay, so it will be polling once again if there is any new check-in happened or not. But what if there is a check-in that happened during that time framework of 40 minutes? Logically, we cannot do anything. So we will be waiting. So as soon as this completes, say at the next 40 minutes or 45 minutes, now as soon as it tries and goes to do the polling, it will say that, yeah, I have found there is a new check-in because last time when I tried to see, it was some 45 minutes back. And then now if you see between that, I see some couple of commits that has happened or check-in has happened. So immediately the next build process or the next continuous integration process will go ahead. Okay, so like this, for a particular period of time or for every check-in that a user does, there will be a build to verify whether his changes is compatible for the product or it is going to be good. So this way, continuous integration mainly helps the developer to find out if there are any bugs that is going to be found. And it also helps the QA in reducing the time in waiting, and also the quality of the product will be higher because we don't want to accumulate everything and make it a mess. It will be quite simple if we can find out at an earlier stage. So that is what we call it as continuous integration. Getting it?
Yes, sir.
So now if you just see the technical term, continuous integration is nothing but a development practice where we will be polling a repository very frequently, and this could be either over a scheduled time or after every build you can keep on monitoring it. And for every submit that the developer does or check-in that it does, you will go ahead with the build process, wherein whatever is the build, that step that you have to take, you can compile, unit test, and verify if things are fine. And in case if it is not fine, you can immediately go back and refer it to the developer. Okay, so that is what is continuous integration is. So if you look what exactly you're going to do as part of a workflow or the step. So the first thing that we need to do is we need to monitor or we need to poll this particular repository very frequently. Okay, that is for every check-in, or it could be the other way of once you finish a build, immediately go and check. So that is how we will be polling. Once the polling is done, you could do a integration. That is what we saw. How do you update your workspace? And once the integration is done, the next thing is you do the build. That is when you will compile the code to create your artifact or executable binary package, whatever you do. And then you can go ahead with doing a testing of some unit test, whatever you want to do to verify things are fine. And then if you want to create a package, you can basically create, and you can also do a deployment to verify. So it doesn't mean just that you have to only compile and see. You can go ahead and do the package creation and also the deployment if there is anything that is needed to ensure end to end everything is fine. Not just that compilation is working, the product is being getting created and it is able to run. So that way you can test completely continuous integration. The major advantage of continuous integration is it helps in immediate bug detection. Unlike the the old method that I was explaining, you'd have to wait for a longer time and a messier project. Because if there are too many active check-ins that is happening on a day, it will not be easy for us. I'm not sure if you have really paid close attention to the repositories check-in. Whenever a release happens, it will be a critical time wherein they have to do a release within like 1 month or so. So what will happen? There'll be so many check-ins, people are working onto it. So in that case, how do you find out if something goes wrong? So you cannot wait. If you say after a half day, if I take, there will be like 15, 20 commits that is happening. So it'll be difficult for anyone to find out who caused a problem or what modified, which is causing the problem. So that way, it'll be very simpler here. The number of check-ins would be less, or the per check-in when you do it, it'll be easy to find the bug because it is less number of changes. That is why it is called as immediate bug detection. And then you don't need a separate integration step like what we were seeing earlier. So you will wait until everyone does the commit and then do integrate and do a build. Whereas here, you can quickly just take an incremental build and try to verify whether integration is also working well, because you're not taking only the file modified, you're taking the entire product or the entire source code of the repository, and top of that you are just putting the latest file, so you're automatically integrating this. Okay. And the other benefit that you can look on the side is it is not just a process to just do a compilation and verify whether you are able to create the deliverable, but you can run some unit test and you can create a system which is going to be a deployable at any point of time. That means you just take it, if there is an application server, try to put onto it, or you want to store it someplace else, you can use that also to verify everything is working. So that's the other advantage wherein you can add whatever steps that you want to the continuous integration. Okay, so this is basically the advantage of continuous integration. Now, okay, so whatever I was blabbering so far, it's just a process. So how is that you are going to achieve this? That is the next question that comes. Because to do all these things, now we need some mechanism through which you can do a polling of that repository and then find out if there is a check-in, and then from there you have to trigger a build where this should happen on a particular machine, and it should be able to do some steps like update, creating workspace, then do the compilation, do the unit text, on all those things. So for every product, these processes or the steps will might vary. So in that case, it is not easy for us to keep on doing everything manually or write some program to get something done, right? So that is when in the market, there are quite a lot of tools which will help us to focus on continuous integration as such. Okay, so by keeping the continuous integration process in mind, they have developed a lot of tools through which we can implement whatever that we discussed just now. So what are the tools that we have? So one first tool which people came up earlier was cruise control. Okay, so that's pretty much when we had Ant, and for Java and .NET they had, but it was good at that point of time. But again, the problem was that you need to tell a lot of things to it. So it could automate, but it was like a framework wherein you have to tell the same thing just like Ant. So if you compare and understand the difference between Maven and Ant, for Maven, we don't have to tell many things. There's only few things. If you try to do it, you can get the things done at a very faster rate and at a very better quality. The same thing if you have to do or write Ant script, we have to feed in each and every information. The same way, the cruise control was not so efficient as we kept having many processes or the steps inside our build process. So then people came up with a tool called Hudson. Okay, so later Hudson was more of a license tool. Then they came up with the open source version of the same source code as that of Hudson, and it was called as Jenkins. So if you look, one of the most widely and popular open source tool which people are using is Jenkins. So that is a complete open source tool, but there are enterprise versions for that also. Okay, but wherein you still have the opportunity of working completely on the open source tool, and there are a lot of features that is available wherein you don't have to do things manually, and that can take care. So why do we need such a tool? Rather than we developing, we can go ahead with a tool for that specific purpose. The advantage here is, the primary thing is, if we do all these things manually, okay, or some kind of way, we need to track everything. For example, on a day, if there are 10 check-ins and you're doing 10 bills like this, over a week, how many bills you'll be doing? Like 50 bills. What failed? What did you help to fix? When did you find out? All those things can be noted if you have such a tool, because it'll have a history of everything what has been happening. But the same thing doing manually is a cumbersome process wherein you need to put a log, maintain that, all those things are being done. Whereas using continuous integration tool, that itself will help us to take care of everything automatically. That is one of the major advantage. And in that way, if you focus why specifically Jenkins is being used, because of its flexibility. Flexibility in the term, Jenkins again is a framework. So what do you mean by framework? So it gives you some option wherein you pick what is the configuration that you want to do for your continuous integration process. Saying I want to do the build. First is I want to find out the polling and then do the build, do the unit test. Okay, fine. Along with unit test, I want to do a deployment. Fine. You just give the information for that. It'll do. Hey, no, I don't want to do the deployment, but I want to connect to some other tool like SonarQube for code quality. Yeah, it can do. Or say, no, I don't even want to know, I want to do a code coverage. You can do that. Or I want to store my specific binaries into some artifactory manager. Yes. So there are options for everything wherein we tell it what is our configuration needed, and based on that it will be running the continuous integration process. So that's why it is highly configurable. And talking about how it does, since it's a framework, the backend task, whatever that it does, that you specify to do, everything is driven by plugins. That means just like Maven, Jenkins is also driven by plugins. So if you want to do a particular task, corresponding to that, you need to install a plugin in Jenkins through which you will be able to do that task. Because if not, by directly, Jenkins will not know what to do. So you install the plugin, and install the plugin, you will get the corresponding options based on that plugin in the Jenkins framework. There you will be putting up the specifications, what is that you want to do, how you want to do all those things. So in that case, Jenkins open source community has lots, like tons of plugins available. So you name any tool that you want to integrate with Jenkins, you can create your own process. So that is the advantage wherein using this framework, you can create a complete system in a faster time, wherein you don't have to keep doing everything one by one. Okay. And finally, the important thing is Jenkins acts as a cron server replacement. So what do you guys understand by cron server? What do you mean by a cron server?
Cron job I know, but I don't know if it's
Yeah,
what a cron server is.
typically there's no
Okay,
difference.
basically the automated jobs.
So the server where you run all the cron jobs is called as cron server. So why do we need
Okay.
that? So if you look, say you have created some kind of tool for doing this and you are running it. Okay. Now, what if the machine goes down? Or if you want to trigger a build on a machine and if it goes down, then you cannot do it, right? So again, you have to take another machine and put the cron entry in that and start running like this. Everything you have to keep changing it and monitoring. But if you use Jenkins, we don't have to worry about that. There are mechanisms through which if one machine is not working, Jenkins will automatically refer to another server, whichever is reachable for doing the task, and it'll work, so that it acts as a replacement for our cron server. So whatever that you want to run, that itself you can put into Jenkins, and from Jenkins you can run it. Getting it? So
Yes, sir.
basically, it's all the workflow wherein you can integrate any tool that you want through Jenkins. So that is the advantage why people go to